I'm super excited to be here today talking about fine-tuning open source models. But before I start, I would like to tell you that we could stay here for hours talking about this topic. However, I am not going to do that to you. We're going to be on time, or I hope so. However, if something is unclear or you need more extra information or something, just we can chat later. And also I'm going to publish a blog post with all this information and the code in case that something is unclear. Say that. This is me, and my name is Maria Jose. And here we have who I am. I work as a data scientist in the intersection between NLP and IoT data. Why? Just life. And I love develop all these projects for having fun, for learning, for sharing, for iterating, and yeah, and why not sharing with you? Here is my contact. And now let's start. How this started? Well, last year was a year where I think that I spent the whole year with this phase. That was my face, because LLMs were everywhere. And it was like, oh my goodness, it's super hype, super excitement, but it was a new publication every week, and new things, and more trials. And then I decided to say, what is the best technique? Because we were having the prompting engineering, the RAG, the combination, the RAG with fine-tuning. And it was like, okay, I am unsure which one I should use for my use case. And this kind of helped me to think when to use fine-tuning. And of course, this is based on my experience, my point of view. Maybe you disagree with that. But the first point is when you have a case when you need a lot of domain expertise and customization. For this case, it's very good to go for this technique. Another very good point that companies love more than the ones who develop is model ownership, because you are going to train a new model, they are going to have this information, and this is always a very good thing to have. And one of the most important to me is data compliance. When you have a case where you have data privacy and security things, fine-tuning is one of the ways to go. However, something is missing here. What about data? Data quantity and data quality. You are going to need both of them to have a good results when you want to have fine-tuning. Which kind of factors do you need to evaluate to say, yes, let's go for fine-tuning? I create this kind of list that helped me to say, yeah, well, maybe yes. Also convince other people that was a good way to go. For me, the implementation complexity is one of the key points. How much effort are you going to invest, and how much benefit are you going to get from this implementation? How much cost are this associated, right? Because you are going to need to invest some money, maybe, or maybe not. We are going to see that we can manage to do things without spending so much money. And how reliable is your system? This is also a very important point in all these LLMs moments that we are living. My personal motivation for go for fine-tuning was to have privacy, data privacy, to have the chance to have my data in my machine. Kind of cheap, depends on the definition of cheap, for sure. Of course, I don't have massive GPUs. As you can understand, if you see my computer, it's not a super massive GPU, or at home. I want to go for a specific knowledge field. I want to do some specific fine-tuning. And of course, if I was asking to myself for the best, simple to deploy. This is going to be out of the equation this time, because we are not going to have time. However, it's true that we can find ways to think how can we deploy as easy as possible, or easy options. Okay, how do we need to, or how can we start? It's, as always, data science pipeline. We need to have our workflows working. And in this case, I summarize it only 3 kind of blocks of steps. That is, define the use case, a block that is data set, choose of a base model, and then all the process of fine-tuning, and of course, the 4th step gonna be the deployment. Oh, and before deploy, optimization, please. Let's optimize before deploy. Well, let's start with defining the use case. Let's imagine that you want to start to fine-tuning your models, but you don't have a real use case right now, right? Because it's a new field, maybe you are learning, maybe not, maybe you have very clear things and you don't need that. But in case that you want to start, you can go to this, the website, to the Helm, that is a project that was developed for Stanford people, where they have in here different scenarios. In these scenarios, they're kind of giving you the use cases. And also, they are providing models that are related to these scenarios. This is a wonderful way to start, because you can go and say, oh, look, this use case, I like it. Which kind of model I can use? And go and just use it. Very, very good. I truly recommend it, or at least take a look to learn from that. But today, we are gonna fine-tune for instructions. We are gonna have local development with a high-quality data set for instructions. And maybe some of you are gonna think, wait, why do we need to do it locally if it's only for instructions? Well, when I was preparing that talk, my goal was to have a private data set, but not a private, it was a public data set, because the thing is that what I would like is that you go at home and you try it, you learn, then you need the data set. But I cannot give you my data set because it's private, and then this is a longer story, right? And what I realized is that, and the previous talk was amazing, because it was sharing exactly these painful points, is that the data quality was very low in the public data set. And I had to invest a full project to have a good data set, to bring you to that. And it was too complex to show you how I did everything, because it was another talk to be prepared. And I thought, okay, well, let's go for a good data set that is available, that you could use, and let's simulate that this data is private. This data is private, but it's not. Well, the first thing is how to build this data set, in case that you want to do it. And goes in the same direction of the previous talk, but I'm super happy. Your data set needs to be specific, needs to be consistent in formatting, and this is something that I learned from the pain, but try to keep it very well formatted, because this is gonna help you a lot to reduce the time and the GPU consumption and everything. Make it diverse. Data sets needs to be diverse. And if you're in data science, they say, yeah, it's so obvious. It's obvious. However, in this kind of projects, has a super relevant to have diversity, but also with a consistency. And of course, if you can have human feedback, include it. Always, always, always. Because you are gonna realize that what you thought that was a good data set at some point was not as good as you thought. And in here goes in the same, quality. Quality even over quantity. This is key to have a good performance in these approaches. And in this case, let's go again into the detail of the example. This is the kind of format that we need. In this case, of course, gonna depend on your model. This means that depends on your model, you are gonna need to format a bit this. In this, I use this data set. This is the one that I was mentioning before, but I version it a bit, just to let you know. However, it's a data set that was reviewed for humans. It was also with reinforcement learning included in the loop. That was super, super good. For that reason, I decided just go for it, because the chance to have success with this project was high. Next step gonna be choose our pre-trained model. To choose the pre-trained model, of course, you can just ask to other people, but a good way that I will recommend is go to the LLMs leadboard from Hugging Face, select what the size that you need, which kind of model, which kind of task you need to answer, because this is gonna be a key point to say this model or this other model. And of course, just try. Currently, if I'm not wrong, they have more than 80K models hosting in Hugging Face. It could be a bit overwhelming. However, it's great to see how the community is contributing to make the field more robust and growing together. And we're back again into the point of locally. What this means of locally. How many of you, raise your hand if you develop in macOS? Okay. What about Linux? Oi, almost 50-50. What about Windows? Oi, okay. Oi, it's very, surprisingly, it's quite equilibrated, very good. However, as you know, for experiences, we have differences. But even if we had the same, if we develop with the same OS, we have different machines with different specifications. I am sure if we take out all of our computers and we start to compare them, probably the chance to have different computers in this room is very, very high, because we bought this, but my specification is this, all of these kind of things. And all of that is affecting to these decisions of local. For that reason, I kind of did an analysis that there was is inspired in some publications that people did. And it was compared two models. One is Mixtral, that is this large Mixtral that with 45 billion parameters, that a lot of people is just talking very good about the results, how good is going on. And then we have Mistral with 7 billion parameters. And I compared the amount of GPU RAM for both of them, for only loading the model, for gradients, and for the optimizer. And I am sure that I should include much more here in terms of GPU RAM. What is the point of this slide? Is the comparison between how much GPU are you going to need for this large model versus this one. If we count all that, we are going to need more than 50 gigabytes. And for this one, we are going to need more than 300. But wait a second, how do we fit that in a local machine, or how do we handle that? This is only if we want to fine-tune our model completely. If we wanted to do it fine-tune for all its parameters. But there are other options. We have go for updating only some parts of this pre-training LLM. And of course, as you can infer right now, we are going to go for this partial approach. How can we do that? Doing some techniques that are named parameters efficient fine-tuning. And here we have some of them, are not all of them, because it was too much information and I decided just not be so much so bad person with you, and I tried to simplify as much as I could. However, we are going to talk about LoRa, about quantization, about QLoRa, that is the fusion of LoRa with quantization, and some adapter information. However, we are not going to go a lot in deep of adapters. Take a look to this publication. It's very good and super informative. Okay, we are going to be focused in this publication about QLoRa efficient fine-tuning. And what I found very, very, very interesting is the information about this figure, about a figure that I'm going to show you later. Because in here we can see that they are talking about LoRa, they are talking about quantizing, about 4-bit precision, and about page optimizer. That if you are not in the field, it's like, I am not idea what are you talking about. What is normal? And we are gonna go one by one, not very deep, just to give you a brief idea of what we are talking about and why this is important, and then go into how we apply that in our code. Then for LoRa is a low-rank adapter fine-tuning method that mainly is to reduce memory, and the idea is use a small set of trainable parameters. We have all the parameters, but we are just gonna train some of them, and meantime the other one's gonna be freeze. Yes, we have quantization. Quantization, if you are familiar with machine learning for microcontrollers or other fields in science, maybe it's familiar to you. The idea is to simplify the weight, the number of that are associated to the weight without loss precision. In this case, it's double quantization. This means that we quantize and then we quantize again. Then we have the 4-bit information. In this case, in the publication, they are talking about 4-bit normal bit float, what is an optimal quantization data type that they create to get better precision. And then we have this page optimizer that what is doing is unify the memory to try to avoid the spikes, to have it more stable. And this is the real figure that I hide to you at the beginning. And on the left, we have the full fine-tuning. That is the one that we will need all this amount of GPU. And as you can see in here, we don't have adapters. What we have is a base model 16-bit, and then we have the optimizers. In the case of LoRa, we have, again, the 6 bits, but in this case, we have adapters that has their own optimizer. And in the case of QLoRa, it's the same as LoRa. However, we start with 4-bit base model, and then we have this optimizer, this page optimizer. And this is the main idea that we are going to use to fit our fine-tuning in our machines. And this sentence, in this kind of projects, it's real. It's very literal because, yes, work in your machine. But when I try to do it in my machine, of course, I import the transformer library from High Phase. By the way, take a look to the documentation because it's very well explained and very easy to set up everything. One of the key points is the bits and bytes configuration, but it's only for CUDA. Oh, wait, I was thinking in just my Mac OS. What now? That was my face when I was super excited. I said, oh, okay, well, then good, does not work in my machine. The option, if you want to go to your Metal macOS, is use this library that was developed for Apple people, that is MLX. It's less flexible that use it in the other approach, but it's functional. You can fine-tune it and works well. However, we are going to be more focused in the other part, in the part that is for CUDA, because it has a lot of more things to do, because in the case of, in the case of this library, it's all in terminal, command line, it's very easy, also I can share it later with you if you're interested, and it's so straightforward. For that reason, I decided to go into this one, and of course I had no time for everything. The first step, we need to load the base model. In this case, again, we import our libraries. We decided which model are we going to use. As you see in here, I just added 2. That is 7 parameters and 1 billion parameters. Why? Because in my old GPU, of the computer that I have at home, it's very old. This means that the 7 parameters was too much. And then I tried the 1 billion parameters and was working very good. The tricky part is that in here, if you want to reduce this change, you also need to play with your data set. But this is another topic in case that you are interested. However, in here, the main thing is that you need to select your model and then continue. Then you have the configuration. I hope that you can see this a bit low, but the thing is that what we are doing here is the quantization part. Here we have the double quantization, and here is the format of the data, and in here we have the compute date type. Once we have that, the configuration set, we are going to need to load the model, of course. It's only using from pre-train, calling the pre-trained model, and adding the configuration that we just defined. Awesome. This is working now. But we need to also add the tokenizer part. In this case, again, is just tokenize the base model and be sure that tokenizer path and the end of sequence is aligned to just to be sure about don't have warnings. What else? Something very important is to know the architecture of the model that you are choosing, because for the next step for LoRa, because you need to understand how many linear layers do you have, what is the name of these linear bits. In this case, it's sorry for Mistral 7. This is very important because this means that each model will be, or each model that has different architecture going to have different information on here, and you need to know what you are using. I am very close to finish, no worries. In here now we have the LoRa configuration. In this case, as only share with you this part, that is the one that I was showing before. This is the target model that is referred to the linear layers. And then, again, we prepare the model, we call this configuration that we prepare for the parameters optimization. We define the training argument. Of course, as you can see here, it's a lot of dots because the code is not complete in here. You need to have a lot of things in considerations, but that I could not add it because also gonna depends of what you need, but will be available in the code. And then, of course, once you have everything ready to go, we can have the trainer that's gonna have all the information. Also, you are gonna take a look to the length of your tokens and train. When you train it, you're gonna take a look how these adapters looks like. But if everything is okay, you can save this model, and then what you're gonna need is merge with the pre-training model. And once you have that, you have your fine-tuned model. Congrats, you did it. It was amazing. However, you're going to need to take a look to the evaluation, see how perform, and long, etc. And probably you're going to need to iterate to everything that you have been doing again and again and again. I don't want to be too pessimistic, but just to let you know that this is the reality. With that, I finish. Thank you very much. These are my contacts. Thank you.